Yeah, hello everyone.
Hello, sir.
Yeah, anyone who's having any doubt? Any last class numerical? Are you able to do it or not? Are you able to do the last class numerical?
No, sir.
No, same as that, right? This is
No,
okay.
sir.
Yeah. So you have written down the question, I guess, of the last class.
Yes, sir.
Yes.
Hmm. So is this visible now? The presentation, the PDF file. Is this visible? The PDF
Sir,
file.
yes, sir. Yes, sir. It's visible.
Okay. Now look, this is a handle, right? In this handle, what you have to do is you just have to find out the R and P first of all. So how to find out that? Now look, here this is a handle, right? So for the first part, for this, how did this 2.5.25 came? You have this, you'll get this PDF in the ERP, okay? So how did this 0.25 came? So it came, if you see the distance, if you see the distance is what? In the, for the I part, I means what? For the X part, that means this side, how much is the distance? So this is 100 mm and this is 150 mm. So total is how much? 100 plus 150 is 250 mm, right? So 250 mm means 0.25 meter. Okay. So similarly in this side, if you see here, it is how much? Look at this. Here it is this one only. So this distance, right? 200 mm. So this is the that part, no? This part will come this side. So it is 0.2 meter. That means 200 mm. Now here, if you see the other side, the last part also, what happens? This is only 200, no? So this 200 will come this side. If it is perpendicular, then it will be like this, no? So it is like this. As simple as that. Now, if you find P, yeah, Max, what happened? Any problem, Max Maibam? So if you write P is what? This is the force, no? Now it is acting on this handle. That means what? It is acting on this side. So it will have one cos theta component and one sin theta. But from this side, it won't have any component. So it is only minus p sin theta j and p cos theta k. Why minus p sin theta? Because it is coming down, but it is in this direction, it will be here. So it will be minus p sin theta, and here it will be in this direction. So it will be p cos theta. So in this way, this is one. Now if you see, you have to write like this. Okay, in this part, these three lines I have written here. Can you see here? Can you see this, students?
Yes. Yes, sir.
Okay.
Matrix form.
Okay, this is in matrix form. Okay. So C into P gives you what? M. That means moment about O. So it is written in this manner, okay? Now after that what happens? You just have to find out the moments, what you need to do is you just have to cross multiply it. That's it. That's simple as that. Now look, mx equal to 0.2 into sin theta cos theta plus cos theta sin theta. Look here. So in this way, you have to find out this tree. And then eventually you have to find out theta and the angles. Okay. So this is how you will be doing it. This is a bit complicated sum. So it is just an extra thing. Okay. This is just an
Sir,
extra. बोलो.
again from the beginning, how it पहले से सर जो
हाँ.
पर्स
पहले से
इक्वेशन
देखो. ये
पर्स
वाला
इक्वेशन
देखो.
हाँ एक्स
125 कैसे आया? ये है 2. ये है 150 है ना. है कि नहीं? है कि नहीं? This is 150, right?
यस सर
Again, it is
यस
in this direction. This is x, na? So you have to consider this part, and what? This part, right? This is in this direction because if it will come here, it will be like this, na? Up to this part. So this is how much? 100 mm. So this is 0.25. Now similarly, here it is zero point 0.2. This is, and here it is 0.2. This is how we will have to do it. Okay. Okay, Temadar.
ओके सर
साइन थीटा सर 0.
तो ये वाला ये इस तरह से आया. देखो ये थीटा है ना एंगल. यहाँ पे देखा एक थीटा एंगल ये हैंडल का.
हाँ सर.
है
हाँ
कि
सर.
नहीं? तो क्या होगा अभी देखो 0.2 मीटर ये वाला है ना. है कि नहीं? हेलो.
हाँ हाँ सर.
हाँ तो ये वाला अगर 0.2 मीटर ये इंक्लाइन है ना एक थीटा एंगल में. है कि नहीं?
हाँ सर.
लेकिन इसको तुमको क्या करना पड़ेगा इस y एक्सिस पे लेना पड़ेगा ना. y एक्सिस तो सीधा है. तो ये चीज ऐसा आएगा ना. मतलब क्या ये y. तो अभी कैसा आएगा देखो ये वाला ऐसा थीटा बना के है. इधर पे एक थीटा बना के रखा है. तो अभी तुमको यहाँ पे एक लेना है. तो ये साइन थीटा कंपोनेंट नहीं होगा क्या?
हाँ 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 सर. हाँ सर.
समझ गया? तो इसमें देखो ये cos
हाँ
थीटा
सर.
कंपोनेंट बन गया है. कैसे बन गया? इसको इस साइड में लाना है ना. अभी समझा? इसको इस साइड में लाना है ना. तो इस साइड में लाने
हाँ
से ये
हाँ.
cos थीटा होगा. इसको अगर ऐसे लगा तो ये क्या होगा? ये साइन थीटा होगा कि नहीं? है कि नहीं?
हाँ सर.
बेसिकली इंपॉर्टेंट क्या है इसका इस न्यूमेरिकल सबसे इंपॉर्टेंट पार्ट क्या है पता है? तुम लोगों को ये दोनों इक्वेशन फॉर्म करना होगा. समझा? बाकी
हाँ सर.
मैट्रिक्स का अगर अच्छी तरह वेल वर्स नहीं है तो छोड़ो. लेकिन ये दोनों इक्वेशन फॉर्म करना होगा तुम लोगों को. समझा? ये दोनों इक्वेशन फॉर्म करने से तुमको क्या मिलेगा? आर
हाँ
इनवर्स
सर.
का मिलेगा और पी का मिलेगा. है कि नहीं? और उसके बाद ये ये जो
हाँ
मैट्रिक्स फॉर्म में इसको लिखने से हो जाएगा. समझ लिया? इसको अगर ब्रेक करना नहीं आता है तो छोड़ो.
हाँ सर.
क्योंकि ये थोड़ा मैट्रिक्स का डिफिकल्ट है ना. तो तुम लोग का मर्जी है. समझ रहे हो मैं क्या बोल रहा हूँ?
हाँ सर.
अच्छा ठीक है. तो हम लोग अभी नया नेक्स्ट स्लाइड पे जाते हैं. ओके ठीक है कि नहीं? समझ में आया? हेलो.
समझ में.
यस
हेलो.
सर फॉर नाउ
हाँ
इट्स ओके
फॉर
फॉर
नाउ इट्स
नाउ
ओके ना. सो दिस थिंग रेमो दासिंग
ओके
समझ में आया?
हाँ 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 सर.
अच्छा ठीक है. तो हम लोग नेक्स्ट पे जाते हैं. तो व्हाट यू हैव टू डू इज look, let us discuss this question now. Free forces and a couple at yeah discuss. We haven't discussed this, no? Did you discuss this sum?
No, no.
No, na. So just write the question.
Yes.
Write the question and draw the diagram. Which one? Which PPT you need? That what file? That matrix file you need. Someone sent me a message in the chat.
No,
That
sir. Your notes, sir.
this one, these are in the ERP, na? This one, that Word file, okay. This thing you need. You can take a screenshot, na? Just take a screenshot of this. Everyone just take a screenshot of this, na? And that Excel, that PDF file, you will get this in the this one, na? ERP only, right? Yeah, just take a screenshot. Is it over?
Show the diagram.
Sir, question is vanished. You are in a different page.
No, no, no. Someone told me to. They need a screenshot of this. Is it taken? The screenshot.
Now, sir, you can back. Yes, sir. Already.
Okay. अभी क्वेश्चन तुम लोगों को ये वाला देता हूँ चलो लिखो क्वेश्चन को लिखो आंसर को मत लिखो so if I hide this can you try solving the numerical huh hello
What, sir?
can you try solving the numerical or shall I do it
Yes, sir. You should.
I should or what I should
Yes,
huh?
sir.
I should do it okay fine did you note down the question in the diagram
Sir.
हाँ बोलो so look at this now you done this now drawing this
Yes, sir.
okay this is pretty simple now now if you see here what happens here the three forces and a couple are shown applied onto a angle bracket so reduce the system to a force and a couple at B we have to reduce this up at B right so look so here 25 Newton force is applied at B right 40 Newton force is applied at C and 10 Newton is applied at A again there is a couple or moment here, 80 Newton centimeter. Now what happens? First of all, what you need to find out is you have to divide this thing into three different components. Okay, you have to divide this thing into three different components. So that means what? I mean, sorry, in x and y component. So what happens? If you can see here, it is what? It's Rx and Ry, right? So you have to divide this into x component and y component. Got it? Students, got it? Did you understand?
Sir.
Okay. So now if you divide this into x and y component, what happens? This 25, right? This 25 is there. So this will be what? Cos 60. This degree, huh? This is cos 60 degree, okay? So cos 60 degrees in this side. Yes or no?
Yes, sir.
Hmm. So if cos 60 degrees is in this direction, so what is the other force that is acting in this direction? Look, this is the x direction now. So what is the other force that is acting in this direction? Can you tell me? What is the other force that is acting in this direction?
10
Ah,
cos
no, 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 no.
90 degree.
No, no, no. What? No, cos 90 degree. Look at this now.
Sir, couple,
Yeah, mu, semi. Hello.
couple.
Couple. Couple is not acting actually. Look at this. This is the force, na? This is in this direction. So if you bring this force, then this is in this direction. We have written this here. Now look, this is the 40. If you see this force is acting in this direction, we have considered this as positive. So that is why this is negative. So this is the other force that is acting in the x direction, right? Yes or no? Is it clear? So after that, if you see for Ry similarly, Ry means what? At y direction, that means what? 25 sine 60 degree. That means what? This is 25 now. This is 25 now. So if this is 25, then this is in sine direction. Now this is in up, but this is down. That means what? This will be minus, right? So that is why we got this. So here one is what? 27.5. Why I? I means x. In vector, I is denoted. I stands for what? X. So that is why I. And 11.65 Zen. Okay. Now look. Now here. If you see the moment is how much? We have to find out moment about point B, na? Because here at B is given. So that means what? 80 is already a moment. So 80 is there. Now this is coming down. So 10 into what? This is coming down and this B is in the right side. Right. If like this. This is coming down and B is in the right side. So we have considered this as positive. So it will be what? Force into distance perpendicular. So this is 10 into 12. Now look at this. Look at the other part. If you see the other part, then what happens? This 10 and 8. 10, this B was to the left, this B was to the right side of 10. But this 40, but this 40 is to the left side. So the sides are opposite. That is why there is a negative sign here. And this is force into distance. So eventually we get this as the resultant force. Clear? Clear everyone?
Yes, sir.
So this is simple. As simple as that. Okay?
Yes, sir.
Okay. So now up to this you have noted down all the things. Did you write this? Did you note these things? Have you noted
Yes,
these
sir.
things? Everyone? Okay. So now we go to the next part. So now we will be discussing the Lami's theorem. Now look, Lami's theorem states that if three forces are acting at a point are in equilibrium, each force will be proportional to the sine of the angle between the other two forces. Suppose three forces P, Q and R are acting at point O. So this is this is point O. Okay. So this is O. P, Q, R are acting at point O and they are in equilibrium as shown in figure. Look, this whole thing is making 360. That is why this is in equilibrium. So what happens? If you rearrange this, they will be making a triangle. Now you all know, if we write in this manner, then as per Lami's theorem, if the angle between Q and R, now look, angle between P and Q is alpha, hello. Oh, I got it. Okay. So
Now we are
Yes,
hearing.
sir.
hello. What is it?
Yes, sir.
Yes, sir. You can continue.
Okay, I am audible now.
Yes.
If the angle between alpha is the angle between P and Q, so this is the alpha angle. Then beta angle between force Q and R. Q and R. So here it is beta and gamma R and P. Then as per Lami's theorem, we get this. This is one. This is an identity, okay? Just remember this thing. What is the formula? This is simply the formula for Lami's theorem. So eventually we can write this one as like this. So remember this thing. Okay? Clear everyone?
Yes, sir.
So remember this one. This one is very important. And the diagrams. Is it clear?
Yes, sir.
So now we will do one other question. A small block of weight 100 Newton is placed on an inclined plane which makes an angle theta equal to 30 degree with the horizontal. What is the component of this weight parallel to inclined plane and perpendicular to inclined plane? This is simple, very simple. So this is an inclined plane. So this one is inclined at the plane is inclined with the horizontal at an angle of 30 degree. Okay. So after that, what happens? The weight of the block. This is the weight of the block. So this is how much? This is 100 Newton. Okay. So what is the component of the weight parallel to the inclined plane and perpendicular to the inclined plane? So you just need to find out. This is the inclined plane. So you have to find out the component of weight parallel to it and perpendicular to it. So how will you find out? Look. So first of all, these are the steps that you will be following. Okay. So x-axis is parallel to the inclined plane and y-axis is perpendicular. So now after that, what you will do is draw the force diagram. This is the force diagram means what? This is the free body diagram. Okay. So this is the free body diagram. How will the free body diagram occur now? If you see here, how it will look like now. Just draw one line parallel to this line. Okay. And you can just extend this line like this. So what will happen? This is 90 degree and this angle is 30 degree, right? So if this is 30 degree, then it will be like this, no? So if this is 30 degree, then this one will be what? This one will be 30 degree, alternate angles. Yes or no? This is parallel and this is parallel. This one is 30. So definitely this one will be also 30. The one that I have highlighted now. Yes or no? Is it clear?
Yes, sir.
So what happened? We've got this as 30. So if it is 30, if it is 30, if this is 30, then the other one will be how much? The total is 90, na? Then this one will be how much? 60, right? Then this one will be 60. Yes or no? Yes or no?
Yes, sir.
If this one will be 60, then this is 60, right? So this is 60 and this one, the upper one, then this one will be also 30, na? Then this one will be also 30, na? So in this way, you can find out what? The components of the force. Okay? That means in x direction it will be cos alpha and in y direction it will be sin alpha. Simple. Yes or no?
Yes, sir.
How cos alpha and sin alpha will be there? Look. Now weight is given 100. So 100 will be acting. So this one, this angle 100 will be acting downward. So 100 cos 60. So if this is 100, then this will be what? Cos 60. And the other will be what? Sin 60. Simple. You found out the x component and you found out the y component. Simple. That's what you need to do. Okay? Clear everyone?
Yes, sir.
Now, if you ask me, if you ask me why sin 60 but why not 30? Do you have that doubt? Do you know the reason why I have taken it as sin 60 but not 30? Any idea? Any idea?
No, sir.
Look, this one is one. It is mistakenly typed, 150. This will be 100. Okay, this will be 100, This will be 100. This will be 100. So now what happens? If you look here, this will be 100. Now, from any body, suppose this is a body. Now it is saying that weight. Remember one thing, the weight is always acting perpendicularly downwards to the body. That means whatever may be the angle, but the weight will always act perpendicularly downward. So if done this, we are getting this angle as how much? This is the angle, no? So if the weight is acting perpendicularly downwards, then in one axis. So this is the x part and this is the y part. So now if it is here 100, so if it is 100, then what happens? This will be 100. What will be this? Cos or sine? What will be this? Cos or sine? This is the theta, right? This is 60. Can anyone say me what will be this?
Cos.
Good. Very good.
Cos.
This will be what? This is cos. So this is cos. Then this is what? This is x part, no? So this is x. So this is cos. Therefore, y will be what? This is y, no? This is y. So this will be what? What will be the y component? 100. What will be the y component? Sine 60. Got it? Is it clear? So that is why we have got cos this one, we have got sine this one. Now is it clear? Now is it clear, students?
Sir, can you repeat once again?
Once again, which part?
Sir, the sine 60 part.
Look, this is the angle, right? This is the angle that it is making. So this is the
Sine
angle.
60.
Okay, wait. This is the angle that it is making now. So if this is the angle that is making, so this side, If you put it on this side, it will be what? It will be cos. But if you put it in this side, it will be sine, no? Yes or no?
Yes, sir.
Suppose this. So here, suppose this, huh? So here we have got angle 60. Here we have got angle 60. So what happens? So this will be cos, na? Yes or no? And this will be what? Sine. Yes or no?
Sir.
Huh?
Yes, sir.
Now is it clear? How did cos and sine came?
Yes,
Is
sir.
it clear?
Yes, sir.
Okay. So this is how it is being done. Okay. So any doubts regarding today's class? So someone came and give the attendance just. I have not asked to give the
Sir,
attendance.
can you
Ah,
recommend a book?
recommend a book
Bo-
for this subject.
Yes, sir. Yes,
For
sir.
this subject, you can buy Bansal. There is one engineering mechanics by Bansal. Don't write the attendance. Please don't write the attendance now. Please wait for some time. Let me finish the class. Then you can give the attendance. No? So the book, you can do one thing. You can buy engineering mechanics by Bansal.
Yes, sir. Thank you.
Ah, so do you need the Amazon link?
Yes, sir.
Do you need Amazon link?
No, it's okay, sir.
You
No,
can
no,
buy.
it's okay, sir.
It's okay, na? You can buy
Yeah,
engineering
I will search for it.
okay, engineering mechanics by Bansal, by Kurmi. There is one. Huh? I have one book that is also good. I'm just writing you the name. Wait, I'm just writing you the name. That is also a good book. That one I have. Uh, I'm writing the chat
Oh,
box. Okay.
Okay.
I have one book. I have got this book. Okay. So this is the book. Okay, Dr. D.S. Kumar's Engineering Mechanics, Statics and Dynamics. Okay. So this one you can follow, or maybe you can follow Engineering Mechanics by Bansal. You can make Kurmi. Everywhere there is same only. They just cover the basic structures. You might find the numericals different. Okay, this some numericals I have made of my own, means, but you can just find out. Okay, is it clear? Is it okay now? Demo.
yes, sir.
Okay. So do you need some other books names? Do you need some other book name?
Sir.
Huh?
No, sir. This will be.
Fine, na? Okay, I got one. This one also is good. You can follow
Yes, sir.
anyone. No problem with that. There is no particular book like that is followed, and you can refer to the notes. This one also.
Excuse me, sir.
Ah,
Sir.
yeah, Oliver.
Sir, that engineering, mechanical engineering by Bansal. Its her name is R.K. Bansal, right, sir?
Yeah, I'm giving you the name. Yeah, RK Bansal only. I'll giving you a name. Okay.
Oh.
Don't
Oh.
worry.
I found the
Ha ha.
PDF for the.
I
I
didn't
found the
hear you.
PDF.
Okay, fine. You can read from that. No
Sir,
problem.
I found.
Good only. It's good only. You can read from that only. PDF. You have found a PDF. Hello. Hello.
Yes, sir.
You found a PDF.
Yes, sir.
Okay, no
Yes,
problem.
sir.
Oliver, you can read from that also. Others can get the PDF from Oliver, no? Remote access and all, if you want. You just can get that. Not a big deal. Okay?
Yes, sir.
Okay.